Yes. Oh, now one more time. Can you tap the microphone? All right. We're good. We're good. All right. So that's that. So I'm going to go through what we talked about before. Okay. Which means they are copying from the last semester and trying to submit it. It's not published. So as soon as workshop one is published, then you can actually do it. Okay. Number two, I want to just remind you of a very quick thing. If you don't do the workshops yourself, you will not be able to pass the test and quizzes. I guarantee that. Guarantee that. Okay? Um, you'll know when I do the first quiz, real quiz. Okay? So I'm going to tell you what the questions are. I'm going to bring the quiz, and all those people who actually did it, yum yum, all those people who have done the project, the workshop, that's so distracted, very hungry. Uh, yeah, so all those people who have done the workshop will do it in Flash and Go, and all the other people will write junk. So careful. Okay, just study and you'll be fine. Uh, so said hello. We talked about scopes and can you just a few of them that comes to your mind? Block scope, opera voice, scope, function, loud, function scope, block scope, function scope,
Local scope,
local scope,
global scope,
global scope, and
no,
file scope,
file scope,
class scope, namespace.
namespace.
Okay, yeah. So these are different scopes. Some of them overlap. Like when you say block scope and function scope, eh, they're almost the same. But function is the thing that are seen in a function. Block is anywhere you start a block, right? When you say file scope is essentially global scope is the same thing as file scope, but global scope externs a file scope variable, therefore it becomes global. And the good example for it was?
For the global scope?
Yes. We have two objects that are globalized, and they are defined in IO stream. These two objects,
C out and C in.
C out and C in, are example of global scope variables. You can use them anywhere, anywhere you include IO. So we went through that. We talked about type def, and we said instead of uh, writing a ginormous thing and go through it one by one and start writing things, we can actually shorten that thing using type def. So any type that you have that you want to rename it, you can actually rename that type to something smaller. And we said, for example, unsigned line int, we're going to make it ULI PTR. It's an unsigned line int pointer. And we mentioned that because it is actually a type, line number 13 makes P, Q, and R pointers. For line number 14, you need asterisk on P and U for them to become pointers, otherwise they're not. Question for the quiz. Okay? We talked about static variables, and we said static variables are variables that they have the lifetime of a global variable, but they have a limited visibility in their scope. So only they are visible. And we gave example for the scopes using the module. And then I gave you the real tags of main. And I said 3 arguments. The first argument is, do you remember what the first argument was? You can simply say pass to the next person. The first argument, remember what it was?
The number of values in the second argument.
Fantastic, pass it through. So when we say, the gentleman at the back, so he said actually correctly, argc is the number of arrays, string arrays in argv. So if argc is 12, it means argv will go from 0 to 11. That's the number of things you have in there, which is actually what? So what are those strings? You want to pass?
Pass.
Pass. You remember? Yours. So what actually is kept in argv? Do you remember that?
Argument variables,
The
string, argument variables.
What are the variables? Which variables? Do you remember which variables?
Environment.
I was gonna get you. So, wait. So, Jana, could you please tell me what actually, am I sharing the screen over there? Oh, yes, I think I am. So, Jana, could you please tell me what argv holds in it? Jana,
Can you repeat that, Professor?
Aha, okay, gotcha. So we have 3. On the screen, you see I have main, argc, argv, and env. I asked the gentleman over there, help me understand that argc is the number of string arrays I have in argv. Argv has the number, so argc is the number of string variables that I have in argv. And I say that's fantastic, but what are the contents of those string variables in argv? That's the question. Now, you see your name on the screen. Tell me the answer. If you don't want to attend the class, the recordings are available. You can come later on. The next person. Chang.
Oh, hi, Professor.
Hello. So what are the contents of argv?
And the RV is the arguments passing into the main function.
Where those arguments reside? You're absolutely right.
Reside within the main function. If that's what you're asking.
I know it resides within the main, but where do they come from?
Come from?
Where do they come from, Muskan? Muskan, where do they come from?
Sorry, Professor, but I don't know this.
No, that's very fine. I don't know. It's fine. That's fine. If you say I don't know, you're my hero. Okay? Don't worry about it. As long as you answer. The problem is that I want people who are online to be online. Okay? And that's what your son's going to tell me.
Yeah, Professor, this is my first time joining the class. I joined the class this week.
Well, all right. And Noah?
Hello?
Hello.
Hello. Sorry, sir. I'm also unsure.
Oh, that's very fine. That's okay. Not sure is good. Not sure is good. Okay, so that's fine. You don't need to answer. Now my friend over here is going to come to rescue. The values are actually what?
Passed by the developer. We pass it to the program.
No.
No.
They are passed from command line.
Command line. You just got 1% per midterm. Okay, reminded me of that. Okay, so
Is
yes, go ahead. Go ahead, I'm listening.
is that from the system environment variable?
Yes, so essentially what happens is this. So if I compile this code, actually I cannot compile it because it's not in this program, it's another one. I'm going to copy it to the current one just to explain what they are. So let me close everything, close all tabs. And that's again hello. Actually, I'm going to put the thing over here. So I'm going to comment the env because I don't want it now. I'm just going to comment that. And I'm going to compile the code. Now that the executable is generated, I'm going to see what is the path of my executable. And my executable should be here. So I'll copy that. Then I'll open the command line. Now inside command line, I'm going to go to the directory which I created my executable. And in there, I have the January 16th exe. I'm going to say 02 January 16. And in here, I'm going to say, hello, everyone. Here I am. I have 1, 2, 3, 4, 5, 6, 7. So argc is 7. And this is argv0. Not that. This is argv0, argv1, argv2, argv3, argv4, argv5, and argv6. And I run this. You will see that everything's going to be there from 0 to 7. Okay? So the first one is the name of the executable. Actually, 0 to 7. I should have put 0 with it. Let me put 0 over there so it actually shows the index. I put +1. I'm going to write it like that. Let's rebuild it. Okay, that's better. Okay, so now we know. Yes. Oh yeah. I can simulate this. I can simulate this command line execution by going to the debug, properties, debugging, and put it in command line arguments. Here are the simulated command line arguments. Show those values. Okay? Look at the first argument now. You'll see the difference. The first argument, see how big it is. Because it's absolute path of the executable. In the other one, I didn't have to put the absolute path. I went to the directory, actually. But when Visual Studio is running, it actually runs it with the absolute path. Therefore, it's a ginormous name for the first argument. Are we all OK with this? Yes. Opera voice. No. It always is what you write. The first argument is what you type in the command line. Because when you write the debugger types the complete qualified name of the executable. It holds the absolute path for it. Only when you run the debugger. So essentially, if you always want to know what is the name of the executable, you have to keep passing our backslashes or slashes, depending on operating system, and see what is the last token. And the last token is the name of your executable. OK, let me demonstrate it this way. This is easier. So let me come back over here. OK. OK. If I do you see that I am in the current directory and the executable is right here. Is that understood? Okay. So in here, if I say 0, 2, 1, and 2, the first argument with index 0 is 0, 2, January 16, correct? But I can also execute it like this. Is that correct? Now the first one is .exe, what you see in a command line. Now if I go one back, now I have to say debug / 02 ex02 whatever I add. And now you see it's debugged. So anything is on the command line is past your program. The debugger passes the entire path of the executable. Yes? The other one will be whatever path it is, or whatever. Yeah, that's it. But the arguments are always exactly what they are. There's no difference. Are we all good with this? Are we okay 1? Are we okay 2? And let me bring our friends into the screen as usual, so I can see the thumbs up. Okay, if you're good with this, please give me a thumbs up on the, or something that you're okay, or thumbs down if you didn't get it. Cheng Cheng, Forsan, where are you? Oh, you have to, at the bottom of the page, there is a hand. Click on that. That shows what you can set your state to. And then clear yourself. So down here, you see this? Click on this. And you can set what you want to do. You can clap for me. You can say thumb down, thumb up. Do like this. And then you remove it again by clicking again on it. Thank you. OK? So that's how you respond, so I can see you're here. I don't want to keep issuing poll. The third argument is environment variable. Now, I'm going to ask the tough question, and I see if you can answer that one. That's yours. Yeah. What's the difference between, so what is EMV holding?
That's holding all the environment.
All the environment variables.
Yeah.
Strings inside EMV. There is name, the content, and extract whatever. But the major between argv and env is?
Well, the ENV is operating system. But once it has to be processed.
Now, how do you know how many environment variables you have in env? There is no argc for it. Do you remember that? Without looking at the screen?
Hold on.
Do you remember it?
How do we know how many?
How do we know? So for the first one, it's argc. Anybody comes to rescue, you're fine. You can say it. Null terminated. Thank you.
Okay.
I have to give you 1% for the midterm. OK, so unlike the argv, argc is a null terminated array of pointers, which means the last EMV that is 0 is null. That's the one that actually holds the values. And when you run the program, it not only shows all those things, it shows all the environment variables that you have on a screen, on the thing. Anything you wish that to know about it, you can even know what is the original system you are running in. Questions? Suggestions? So now we know we need to review. How we do this curve of forgetting when I mentioned in class? How do you study for the subject?
Whatever you study for that day, go home. And then first day is 20 minutes, within a week 10.
Thank you. First day, when you have the lecture, 20 to 30 minutes review of the lecture. A week passed, 10 minutes. A month passed, 5 minutes. And it's submitted to your long-term memory. The way I see it, none of you did 5 minutes. except 1 or 2 maybe. Okay, so please do it, okay? And also we did the OOP345 assessment for the other class, highest score on a very simple question that you're going to get. I'm going to give it to you, was 70%, okay? So please, you have to study, okay? You have to study, all right? And I'm going to tell you, you tell them your results. Don't think that I'm not. And yeah, but 70% is good. If you have 70%, it means you're really good. Okay? Because I marked it as if you are an OOP345 and you came from 2. You missed that test. Please don't come. It is not counted. It is not weighted. It has nothing to do with your OOP345 mark. Okay? And I will remove it completely after we are done. Okay, so that's that. Questions? Suggestions? No? Okay. So A, main args review. .cpp. Now, let's talk about, continue talking about statics. Now, when we talk about static variables, we said that static variables have the same lifetime of, did you answer already? No. So, we said that static variables, they have the same lifetime as the application, but their scope variables. Let's see. Variable statics have more meaning than others. For example, if I have, oh, not this one. Say I have a class called num, and in that class of mine, I created a static member variable that I call it s. And what I do over here, I add 1 to the value of s when the object is created, and use s by 1. So like that, I am capable of seeing how many objects of type num is created, because statics are created once, and they're not created again. So that kind of brings, wait a minute, it goes against encapsulation. That is, what is encapsulation? You remember?
So that
I say, what is encapsulation? You don't say encapsulating members and data together. You have to never use the name of what you're describing in a thing. Packing, do stuff like that. So packing or putting together the data. So, and the side effect of encapsulation was, it's not only the data and its relative actions. It also did something we called information space, starts with an H. Information hiding, and privacy. It hides information, which means if I create 50 instances of num, each num has its own value, right? But when you make it static, then, wait a minute, I can only create 1 instance of that static variable. If I can do that, then although S's accessibility is within the class itself, but all classes share the same attribute, which means if I create if I create 4 instances of num, each num has its own value. So if this is the value, not that. If this is the value, then each one will have its own value. But because S is not a regular variable and it's static, only one instance of it will get created. So essentially, it belongs to no one, and it belongs to everyone. They all share the same value. If the first object sets it to certain value, the second object can read that value. That's why in the constructor I'm adding 1 to it. So as soon as the first object is created, it adds 1 to it. So like that, in the constructors I'm adding 1 to S, and in the destructor I'm reducing it by 1. Therefore, I can keep track of how many instances of the object is created. Does that make sense? There is one problem. If it does not belong to anyone, then who initializes it? No. How do you know which one is first? Dictate which one is first. First one is not the one. You actually have to manually do it yourself outside of the class because it belongs to no one, which means down here you have to say integer value num s, and you say equal to 0. So you create the static variable out there, and you set it to whatever value you want. You initialize it, and you make it available to all the classes. It's exactly like globalizing, where you create a variable and you do a return. You create the static individually because there's only one instance out of it, and then you make it available to everyone by putting it in a class. Therefore, now it starts with the value of S. Because of this fact, S exists even before any object is created. It essentially belongs to the class, not the object. What is the class and object? No, no. Let me see if Muskan can tell us. What is the difference? Like, you can tell me what class and objects are? What is the difference between a class and an object?
So an object is like an instance of a class. So
thank you
we
very
have
much.
created.
That was enough. That was enough. That was enough. Beautiful. Fantastic. Okay. So that's not gonna get you a percent because that's an OOP345 concept. So integer ABC. Integer is the class. ABC is the object.
Yeah, I just have a question.
Yes.
So we initialize the S outside the class. Can't we do it when we are doing like the static int, like in line 5?
No. You can't.
Okay.
Because for that to happen, okay. If I do this, when the object is, that answers the question, right? Because static. Now, the nice part is that you can actually make a function static. You cannot make, member function, a method. You cannot make a regular function static. It doesn't make sense. All functions are static. All non-member functions are static. They are in the program. They're not going to come and go away. It's the member functions that come and go with the objects that they create. You can make a member function static. And when you make a member function static, what happens is that the function you create becomes an outsider too. And they exist outside of the class, but it has access to the class. But, question that I have, can a function that is static access the non-static values? Of coffee in front of you. And I'm going to say, pick the coffee. What you going to tell me? I said, pick the coffee, a specific one. Which one you going to pick? No, I'm not pointing. I'm just saying, pick the coffee. Not any. I said the English, the. It means a specific one. No. If I say pick a coffee, you could pick one. I say pick the coffee. When you put the name of the variable, you're specifically saying I want the variable, not a variable. There's no randomness. I'm saying pick the coffee. The answer is going to be which one, right? And you don't provide that in a static method. A static method, if you put the name value in a static method, it gets confused. If you have 50 objects, there are 50 different values. Which one to pick? It's one-to-many relationship. Therefore, impossible. Remember, members. Your quiz, okay? And don't tell me I didn't know what the questions are. I'm telling you what the question is, okay? Now my question is here. Can a regular function access a static value? The answer is yes, it's many to one. Okay? It's many to one. Each one of them can access it. And regular functions can always access static functions, but not the other way. Remember that. So that's all about statics. So now I can actually run the main part too. So as you see, the interesting part is that the static methods in other languages, I think it's in C# or Java. Like a namespace. You can even call, so I can even do this. Take a look. Before I create anything, I can actually call the function. Because the function is static, it exists without instantiation. Therefore, you can call it. Okay? That's why if you look at my utils that are, remember I did the utils in OOP345? I'm going to create the same utils over here, but this time, all my utility functions are going to be static because I don't need to instantiate it anymore. These are utility functions. They don't belong to an object. So you will see that we're going to say utils, scope resolution, str copy, for example. We'll come to it soon. Okay? So that's that now if I run this beautiful function of mine. Like you can walk through it and see what's going on. But essentially it tells how many instances are created. You see object number 1, yada, yada, created. So one by one, you can actually it just can't exactly. Do a dynamic thing and don't delete it. You see, it's going to remain 1 or 2 at the end. But that's what it is. Are we good? Okay. So just go through this one more time. So I'm going to bring the foo at the top before these things are created. So I'm going to go. So I'm going to come over here. First, I'm going to print the number of instances. Let me just bring this to left and this one to right. So now let's go. So I'll go to foo. As you see, n is getting created 10 times. Each time the constructor is called, it's going to add 1 to the value of s, and it's going to print it. And because I have 10 values created over there, this is going to get executed 10 times. So 10 objects are created. And if I actually come over here, you'll see that it's the number of instances is 10. I get out. I'll come over here. I create 2 of them. As you see, 1 and 2. Why it's 2? Yes, because we did s minus minus, and foo, all the variables in foo are dead. After foo is executed, all the numbers are going to be gone. So there is no more. And when it comes back over here, now I have that. Are we okay? But if I call foo over here, and I run it, so the first one is executed. When it comes over here, now when it goes over there, it's going to go up to 12. Because when foo is calling, the second foo is called n and m existed. Therefore, it became 12. So it's really shared. It has nothing to do with your scope. The static variable remains the same. That's a beautiful walkthrough for a test, too. OK? So it actually shows everything. And you can see the number of instances at the end, what they are. And we get out, and we are good to go. All right. So now we know all about statics.
Excuse me, Professor.
OK, go ahead.
If the statics function can't access the members of the class, then why it should be placed inside the class?
Why they should be inside? You're saying, why do I need to have a static method inside the class?
Yeah.
OK, let's put it this way. Let's say you have a class called name. OK, the question that you have requires some programming. Give me a second. Let's say I have a class called name. Okay? I have character m name that is maximum 1. Now, in the constructor, I want to get the name and copy it over there. So constructor of name goes name. character name. Sorry, const character name. Okay? And I want to copy it over there. But I don't want to use string header file because of all the secure thingy that I'm getting. So I want to write a function that copies a string for me for name. So what I'll do over here, I'm going to say void strcopy, right? And in here, I'm going to say a character destination and constant character pointer sorts. Okay? Now in here, I'm going to say for integer I set to 0 and source I and destination I set to source I source. Sorry. Oh, not source, destination. Who asked the question? Who asked the
Me, sir.
Okay, so Insan, right? So
Yeah.
Insan, now take a look at this. So this str copy, I have a question. This is needed for name, right? Because
Yeah.
I want to do copying in it and I don't want to use any library. Now, is this a string copy belong to any specific object of name? No. Its job is to do some dirty work for all names. Therefore, it's a utility function. It doesn't need to have access to anything. Therefore, public static.
Oh, okay.
So why do we need to have a static method?
Yeah, I got it.
Because the logic belongs to class.
Yes, Professor. Thank you.
No problem. Okay. That was a good question, by the way. So in here, I'm going to str copy into name, the name, so on and so forth. All right? All right. And sometimes these static methods need some initial values to work with. Then those become static member variables. All right? All right. So this is going to be y static members. Any other question, people? Questions coming? I'm happy. Suggestions?
Excuse me, Professor. Can you show me the code once again?
Show the code one more time again.
Yeah.
Here. Why, you want to copy it or something? It's on GitHub. Everything's on GitHub. It's got to go on GitHub.
No, sir. If the str copy is static, does this it has access to mname, which is not a static variable?
Of course, because I'm passing it to it. I'm not using mname here. I'm passing the address of mname to destination.
Oh, okay. I got it.
Okay. Yeah, if I use the mname over here, I couldn't have
Yeah.
access to it. You're absolutely right. I'm passing it to it. Good call.
Yeah, okay.
Good call. Good call. Are we good? All right. No, extern is for globalizing objects. It has nothing to do with static. Oh, no, no. Maybe you can. I don't know. I don't know the answer to that. Try it, see if you can. I don't know. So having a static member and externally? No, you can. Just doesn't make sense. I don't know. All right. All right. Static methods. And is leaving. I'm going to take. So I just made this thing a little fancier, and to see all these, go to the. Oh shoot, where is the? I should create a link for it. So GitHub, not Google. GitHub Fardad. Repository. Oh, this is the one, right? This is the one. So let me copy this. Not copy. Actually, put it where. Okay, so yeah. So if you go over here, I have, for example, a better example for Y static. You see that? When you click on it, then it shows what it was and what I change it to. You see that? It's a good idea to go through the things as I commit through my codes. I explain in my commit so you can see exactly what happened. Okay? Also, that reminds me, thank you for all those who did Workshop 0. Okay? Some of you did it, but you didn't follow instructions. Like your README file list is not correct. It's in one line. When you create something, was it you? You updated it. You did OOP345. Shame on you. Yeah, so follow instructions, please. Like follow the instructions and create. Like, some people add me as a collaborator, and they don't even have it read. It's an empty repository with nothing in it. What do I need it for when I don't know who you are? And remember, create these things with your own private email. Don't use Seneca email, because if you were in an organization, then it won't allow you to add me as a collaborator. If you were, you can create with your own account. You can always change this later on. You can add many more emails if you want to your account, but create it with your own, so you have your own identity on GitHub. After you graduate, the organization is going to be gone. You're not going to be there. So make sure you create your own. Okay? So that's that. So it says standard signed integers, and it doesn't put signed in front of them. So it's supposed to be signed short int, signed int, signed. So if it says standard signed integers, they're all supposed to have signed in front of them. Okay, that's a mistake. I have to ask them to fix it. Okay. So, and assigned character and characters, so on and so forth. So please go through all these things and read it. I'm not going to waste time, go through it and tell you this is an integer. Please go through it and see what it is. Let me see what are the other points that I have to cover over here. Something from IPC that I have to remind you at. Floating point numbers are simulated floating points. When we say floating points, essentially they are real numbers with partials. The partials that you have, first of all, by the way, at home, can you hear me? Say something.
Yeah.
Oh, perfect. Okay, good. So floating point numbers, any type of floating point, float, long, double, these are simulated values, which means when you reach to a perfect logical conclusion that the value that you have is 3.5, it might be 3.4999999, or it could be 3.5000000001. And if you check this for equality, then you may get a false answer, although the logic dictates that they are the same. Because the value you are testing with is 3.5, but the value that you have over there is 3.499999. From computer's point of view, these two values are different. Because of that, whenever you want to check floating point values for equality, you reduce one by the other. You check the difference to make sure it's between some negative and positive value. So if your precision is by percent, the difference between the two should be between minus 0.009 and positive 0.009. One less than minus 0.1 and one more than, and you know what, you follow what I'm saying. So that should be the precision you are looking for. And like that, then you're guaranteed that the two are the same. Remember that, okay? Or you can go to math library and use absolute value. And if you don't know what absolute value is, go study math, okay? Oh, it's so fun to teach like this. I'm just going through it. Please read all these. You know, so the auto that we have, auto essentially is something that you're going to find the need for it a few weeks from now. For now, we have no use for it. Automatic variables are automatic types are essentially done through initialization. Anything that is being initialized, when you put an auto for it, it looks at the initialization and automatically sets the type that you are initializing to the same value of the other one. Don't be mistaken. You cannot have an automatic function argument. That's not the same, because it's every time it's called with a different thing, and this is happening at compile time. So you have to make sure that you understand this. Okay, very important to know all this. But what is it used for? We'll find out later on. Later on, you'll find out that because we are using templated stuff, classes and stuff like that, it is impossible for you to know what the type is that is coming through. Or you can, but you have to write a huge thing to write what the type is. When you do that, when you have something that the name of the type is like 45 characters long, it's easier to say auto equal, okay? And later on, we'll find out that you're going to create what we call lambda expressions, which essentially are, small little instant functions. You'll see, okay? We'll come to it. When you do that, auto is used for them as well. So use auto. For now, just know that auto automatically sets whatever you are setting to the type being initialized to, and read through it and you'll see what's going on. Alignment. So, who has the microphone? Do you remember what sizeof was from OOP345? Did I even mention what is sizeof in 244? So what is sizeof? Do you know what is sizeof? Do you know what sizeof is? An operator. It's not a function. Looks like a function, but it's an operator. Do you know what it is? Doesn't matter. I'll explain. Never mind, dear. Sizeof tells you how many bytes something takes in memory. To sizeof operator, you can give two different things, either type or an object, either a class or an object. And it tells you what the size is. So essentially, I can say cout sizeof long, and it's going to tell me what is the size of long. 3 years later. That is 8 bytes, right? And I can actually have something like and I can say D. That is essentially a long double. And it's going to tell me the size is 8, okay? Now, depending on what the thing is, let me see if I can actually, I think that's going to work. Still 8. I want to try something. That's 4. Still 4. I know it's going to be still 4. And I'm going to say, never mind what I just talked about. Yeah, it's still 4. Anyways, well, don't trust it. The size changes depending on what the platform is, okay? So if you're running on a microcomputer, when I say microcomputer, I mean remote control of a TV. You're writing a code for it. The integer over there might be 2 bytes. You don't know. It depending on your platform, the size will change. That's why we have sizeof. So, and the sizeof that we have is not only that, but also it can be actually used for things like compound types. So I can have something like this. So what the size is going to be, you think? From long was 4, right? Or it was a long is 4. No, long. Let's see. Before I actually show that test thingy, let's put all those things up here. So I'm going to have, let's do it like this. C out long. So this one is char. The other one is long again, and I have a double, right? Now, having said that, running this, we have these values, right? And let's do the math. So I have 4 plus 1, 5, 5. OK, so that's right. Well, let's actually see what the size is. It's one of those what the heck moments. The heck? This is called alignment. How the hardware actually goes through your variables. Like if you have a double and you want to put the double in memory, how can the system find out where the double is? It goes through his address, right? And the funny thing is that when you have double, it can only count by 8. So if you are putting a double in memory, a double is doomed to be in an address that is divisible, whatever you call it, by 8. You cannot have a double sit in the address 7. It has to be either 0 or 8 or 16, or so on and so forth. If you have a character, it can sit anywhere. Right? If you have a long, it has to be what? 4, 0, 4, 8, 12, and it goes like that, correct? Now, just think about it. You put the first long in memory. OK. You first put the first long in memory. OK, so the first long is 4 bytes, right? So this is my memory, right? You think it's 24? I hope so. We'll find out. Anyway, so, and I'll put the addresses 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 will go. Okay? So the first one is where is it? Is a long, right? So, and long was 4 bytes, correct? So that's the first one. Correct? 0 to 4. That's 4 bytes, correct? And now I put the character, correct? Right? Now you want to put the next long. Can it put it here? No, it's not divisible by 4. So it has to keep going until it puts this one over here, correct? Now it wants to put the double after that. Can it put double at 12? No. It has to keep going until it gets 16 and it goes down to 24. Correct? So all these memories are wasted because of the alignment problem. So how do we make it as small as possible? The answer is, and it doesn't always guarantee that, the answer is to always sort it in a descending order. It doesn't make any difference to you. The name of the variables and everything are the same, correct? So I'm going to call this one test 2. And now let's take a look at test 2. Still 24. Why? Still 24. In the other class, I gave an example that was different. I'll bring that one up, and I'll tell you why. And I say why it doesn't make a difference all the time. Now, let's put the other one. Should I bring the other example? Actually, this is good. This is good. Let's do this, and then we're going to do the other one. Oh, where is it? So now, for the second one, I have a double first, right? And I have a long, and I have another long, correct? And I have a character, correct? Seems like everything's good, right? What if they want to create an array of test 2? It means the next element should sit here, correct? It can't. If I want to create the element for it, if I want to create this as a structure, the first double is going to sit at address 17, right? But it can't. It has to go up until it reaches to the one that is actually divisible by 8. And compiler calculates that. Therefore, it knows. And still, it's for 24. But let me bring the example I've done for the other class. Yes? Oh, yeah. You're going to see if you remove the char, you'll see suddenly, poof, it's going to go down. Yeah. But give me a second. Well, I think it was this one. We'll find out. No, not this one. Was it the last thing we talked about? Shoot, going back over there. Yeah, there you go. I'm going to call these different. Actually, test 3, and I have a double and an integer, and so I have a double character. So I'm going to put int over here. This is good, right? Yeah. There you go. So you see 24, 16, 16. So first one is having 24 of them. Now I can start doing it exactly as I've done over here, and you'll see the alignment. Do it at home. You will see that sometimes rearranging actually saves you memory. Okay? But alignment and sizeof are not the same. Sometimes you set something, the size becomes 24, but alignment is 16, which means anywhere, anyhow you put the structure, it can actually sit as a certain place. That's the alignment. Alignment tells you at which address, what is the size of each step that you can go and put it in that address so it is valid. That's align. So you can actually check something called align of. You see? The alignment of all those things is 8, which means if you start the structure at the address that is divisible by 8, everything will sit at a valid value. So alignment and sizeof are two different things. Sizeof for you to actually set it in a way so your data becomes shorter. If I'm supposed to have an array of 2 million of those, imagine how much space I'm going to save by just sorting everything in descending order. Alignment is for you to see where they sit in memory when we go in higher level of programming. Or better to say lower level of programming. Low level programming with dealing with memory, but more skillful in programming. Let's put it that way. Okay? And not only that, you can actually force the compiler to create this structure and set it to sit in specific alignment. You can actually say, I want the alignment of this thing to be 16, even if it's 8. You cannot just put any alignment. The alignment should be valid. Okay? It should be something that exists. That's why it's very complicated. You're not going to deal with this. It's just something, I don't think in any workshop you're doing this at all. But it's something that you need to know when the time comes. So, and you're going to have it in a test and a quiz. So, so have it in mind. But it's very important to know it. So if I bring it up over here, it shows examples of how to. So these are align of. Align of, as you see, it says what is the alignment for it. You see, struct align as B. So essentially says, although the size of this structure is 5, and the alignment is probably 8, but set the alignment to 16. Why? Because the sky is high. I cannot explain to you in any way, so which is too rich for us, okay? But say the way the data is stored in the way the sectors of the data that is stored in your storage device has segments that are 16 bytes. And no matter what you do, the structures that you're going to put over there and save one by one is going to go to segments of 16. And because you want to save in time system processing to save your file in proper alignments, you set your data to proper alignment so it's faster. You set it to alignment, align as something. Okay, so it's tough to explain what you need to do, what you need it for, but just be aware that you can. Okay, so that's that. That's that. And let me see, just a second. want to see the next topic that I want to talk to you about. Okay, so this is good. So this is CE. Okay. What does this mean? Return to the operating system. So the return value that you're returning actually returns the value to the operating system, which means if I recompile, rebuild this code, I think I still have this open, don't I? Yeah. So I'm going to go cd debug. So if I go 02 dash something, 02 dash yada yada, and run this, nothing happens, right? But if I say echo, it's going to be 1, 2, 3, 4. You see that? So the operating system has the value that you have. I think it's $! In shell basket. I don't remember what it was. But there is something that you can actually get that, see what is the error level in Linux. So these are, so why do we return these things? So the script that is running your program, for example, how do my submitter knows that you had compiler errors in your compiler? How do you think it knows? Because compiler returns a value after the compiler fails. And I read that, and I know that your compiler didn't compile it successfully, so submitter says, you had error problem, go find out what is this and that. I'm not doing magic. I just see what the compiler is returning. You follow? Got it? All right. So that's return. Okay. What else do we have? Let me see what is the sequence of things going in here. You have pointer references and arrays. So before this, I just want to see, because in the sequence that I have over here, I'm talking about certain things that a bookmark. What bookmark? Okay. So that is not needed. I just wanted to, because the sequence of stuff over here, I put something over here to explain what everything is. So we talked about type def. And what type, we talked about type def, right? I explained what type defs are. Now let's talk about pointers. What's the time? We have 10 minutes. Okay, let's do a query. Anybody knows what is a pointer? I cannot hear you. What do you think people at home? He's like. It's a variable that holds the address of another variable or another thing. Don't give pointers extra credit again. Okay, I always mention that, and I don't want to take you through my IPC 144 slide. I do it every semester for OOP345. I'll put the slide over here. Please go through it and see what it is. And if you don't understand what pointers are, and come to me and talk to me. Pointers are essentially variables holding the address of other variables. Pointers are nothing but unsigned integers because they cannot be negative. There is only one difference between a pointer and an unsigned integer. If you add 1 to an unsigned integer, 1 will be added to it. If you add 1 to a pointer, the size of the target will be added to it. So if you have an integer pointer a and you have the value 0 in it, if you add 1 to it, the value becomes 4. If you add another 1 to it, the value becomes 8. And that's how pointers work. So you can have arrays. The index that you put over there, you are actually saying add 0 to the address. The name of the array holds the address of the beginning of the array, and it's a pointer to the beginning of the array. So if you have an integer array, the name of the array is an integer pointer to the beginning of the array. When you say index 0, it means the address inside the name plus 0. That means the first one. When you say 1, it says address of the array plus 1, which is the size of the target, becomes 4, so it goes to next element. When you make the index 2, 2 will be added to it. Therefore, it's going to be 2 4s, that is 8, and it keeps going to the next one. And that's how the arrays are set. Are we okay with this? People went looking at right side up. That means they're trying to get help from the deity or something to understand what's going on. I think I have to. So you know what? It's 3:05. Who's going to tell me next day that we're going to do pointers? Are you going to tell me? So remind me the next time we are coming in. For that, we're going to continue from pointers. So pointers and stuff like that. I explained that in the other class, and I'm going to explain it over here about the way this class works in meaning of learning. Okay? So if this is time, and this is knowledge. Okay? This is how it goes through. You see that over there, right? I'm not talking to myself. Okay. It goes like this. And this is midterm. Okay? So I'm going slowly now because the material is so many and there are easy things to go through. Please don't be like today when I come and ask a question. I see you have no clue what I talked about last time. Please, I beg you, go through the notes and see what I have done and try to remember what I've done. So when we come to the next one, when I'm talking about pointers, and you know what sizeof is. So when I talk about pointers, you know what's going on. I'm going to go through the pointers very quickly in 10 minutes to tell you what pointers are. And then after that, we're going to dig into pointer to multidimensional arrays, pointers to pointers to pointers to pointers to pointers to pointers like that. We're going to go through all that to see what does it mean. Okay? So I don't want to fry your brain anymore. That's for today. And please remind me. Remember, we have lecture all the way through. No labs. You're coming for the lab. You're going to be here in person, and we are doing a lecture. It's going to continue like that until the workshop comes up and we catch up with our stuff. Okay? All right. No, you can. Okay, about workshops. Okay, you can submit your workshops from anywhere. It's not like OOP244. Okay, OOP244, we kind of start dealing with students as mature students, which means we give the workshops 2 weeks ahead, and we're going to say, you do it. Now we're going to give you only 4 workshops, and we're going to do it. You can choose to do it yourself, I mentioned, or you can choose to ask ChatGPT to do it for you. Okay? But the difference is that you won't be able to do the test. Careful. Okay? Please do it when it comes up. Okay? It's not still up, but you can do it from anywhere. Okay. All right. Have a beautiful day, everyone.
Professor.
Yes.
I think I have not been added to any of the teams, Microsoft Teams. Can you please add me? I tried to schedule an appointment with you.
So what I want you to do to please, if you don't mind, please read, go through the, please log into the Blackboard. Go to faculty information. So you go to Blackboard, log in. We are OOP345NBB, correct?
Yeah.
So you go to Blackboard, and you go to faculty information. In here it tells code to join the team. Okay? So if you, either you can just ask to join, I'll respond to it, or you have the code. Okay? Please read the information first. Thank you. Have a good day.
Okay.
All right. Let me give me a second. I don't want to record my private. Thank you. Oh, thank you for turning. Did you turn it off? Thank you. I just wanted to make sure the battery is not gone.